All right, hey guys, so we're looking at finding the length of a line segment with given some endpoints A and B. Well, if we're given this line, we'll go ahead and make ourselves a coordinate plane. Okay, make it a little bit of a brighter color. A is over here, -4 and 7. And B looks to be 3 is the x-coordinate, and 1 is the y-coordinate. So there's B right there. And I'll try and connect those 2 points. It's pretty good, not too bad. And our goal here is to find the length of this. All right? We'll call it, I don't know, D. A lot of times D is used for the distance between 2 points. In fact, here is the formula. Now, if you look closely, if I were to break this into if I were to sort of focus on this section here and that section there, you would immediately say to yourself, hey, that looks like a right triangle. If I label this y and this x, then what we're doing here is we're effectively looking at this y distance and this x distance, and we could put those into the Pythagorean theorem, in which case my formula would be d is equal to x squared plus y squared square rooted, coming straight from the Pythagorean theorem. So effectively what we have to do is figure out this x distance and this y distance as well. Well, that's what this formula does here, right here. This is x2 minus x1. It's basically finding the difference between the x coordinates of these 2 points and the difference between the y coordinates of these 2 points. In fact, this y coordinate is 1 and this y coordinate is 7, and the difference between those would be 6. And you can see here, once we put it in the formula, it's going to be 7 minus 1, or 6. So what we'll do is we'll just, distance is equal to the square root of x2. We'll call this point 2, and we'll call this point 1. So that means my x-coordinate for B is my point 2, so I'm going to use 3. And now I need to use my x-coordinate for the first point, which would be A, because it's x2 minus x1, so 3 minus a -4. All of that squared, plus. Now I do the same thing for my y-coordinates, and so my second y-coordinate is a 1, and my first y-coordinate is a 7, and so it's going to be 1 minus 7 squared. Okay? And if you look closely, I get a -6 in here, but we're going to square it, and here I ended up getting a +7, and we're going to square that. And so doing this, distance is equal to 3 plus 4 is 7 squared, plus 6 squared, square rooted, so the distance is 49 plus 36 square rooted, which happens to be 70, 79, 85. So the distance is the square root of 85, which is, I don't know, maybe a little over 9 or so. So the distance from here to here is a little over 9. Okay? And we can basically leave it as a square root. Most textbooks and math teachers accept the square root as the possible solution. It's fine. Let's do another example here. Let's calculate the distance between points A, which is here on my graph, okay, and the line, y equals 2x plus 3. So that's this line right here. So if I were to go from this point to the line, there are many distances. In fact, I could go from here to here. I could go from here to here, from there to there. I could go from there to there. But when you're asked to calculate the distance between a point and a line, you're generally asked to find the shortest distance. And that shortest distance is always going to be found by building a new line, the red one. And that new line is going to be perpendicular to the blue line, okay? And now what I'm going to do is I'm going to try and find this point B where the red and the blue lines intersect, and then I'm going to find the distance between A and B. Okay, and if you look closely, I've got a little triangle here. It looks like it's going to be 2 in the y direction and 1, 2, 3, 4 in the x direction. So I'm just going to guess that my distance is actually 2 squared plus 4 squared, square rooted, because remember, our distance could be figured out by doing the Pythagorean theorem with the sum of the squares of the y and the x directions of the differences in the through the points here, the coordinates. So it looks like we're going to end up getting 2 squared plus 4 squared is going to be 4 plus 16, or the square root of 20. Might be an answer, all right? But let's say we didn't have the graph, actually. What if the graph was not provided? Oh my. And we were given this question, okay? Well, if that were the case, we wouldn't necessarily, and even if we made the graph now by hand, we wouldn't necessarily realize that the numbers here are actually 2 and 4, because the intersection, we would just be drawing it by hand. So for example, if I just draw the two lines, like the one line was like something like this, and then the point is here, I wouldn't necessarily know that this is exactly 2 and this is exactly 4, and my whole answer could just be figured out geometrically, okay? Well, since that's sometimes a possibility, let's see about what would we do if we weren't given the graph, okay, and we were to solve this algebraically, all right? So what we would do is we would attempt to build this pink line and find the intersection between them, and then find the distance between the intersection point and point A. So let's start by building the first line. So step 1, build the perpendicular to the line, okay? Build the perpendicular to the line. Well, our line is y equals 2x plus 3. So y equals 2x plus 3. And the perpendicular slope is going to be, slope perpendicular to 2, is going to be a half because it's reciprocated and negative, so it's a negative 1/2 slope. If you look, this pink line does have a negative 1/2 slope. So that's what I'll be doing. So then I'm going to use point slope form. So it's y minus a y coordinate of any point on the line. Well, this pink line, I know that I've got a y coordinate of 5 here, and equals the slope of that line, which is that, and then it's x minus any x coordinate on this line. I'm going to use the 6. Remember, this is point slope form for a line where you're given the slope. If you know the slope, you put it here, and if you know a point, you put its y coordinate there and its x coordinate here, okay? Well, that's my line, and now what I have to do is I have to find the intersection between that and this, 2x minus 3. So I have to find the intersection here. That's our next step. Now, could use substitution or elimination. But for this one, look, y is already isolated in the second formula. So I'm just going to take this second formula here, and I'm going to sub it in for y right there, okay? So that's going to be my easiest way to find the x-coordinate of point B. And I'm imagining we're going to find it as to be a 2. So I'm going to take my point slope form, y equals y, or 5. Oh, I messed that up. Hang on a second. Y equals, let me start over here. Y minus 5 equals a negative 1/2 x minus 6. And remember, what I'm going to do is take this, just this part, and I'm going to sub it in for here, right there, okay? So I'm going to put the 2x minus 3 here, the 2x minus 3. And now if you notice closely, or if you're looking closely here, all I have is an x and an x, and I can isolate for those x's. So let's do this. It's going to be a 2x minus 3. Hang on a second, guys. Let's say plus 3 here. Plus 3, and a plus 3. This should be a plus 3 right here. Okay. Minus 5. We're covered. I almost messed that up here. And then we got x minus 6. Oh, I guess I'll distribute that in right now. I hope you all don't mind. I'm going to do 2 steps at once. I'm going to distribute the 1/2 in. So 1/2 x plus 3. So if I distribute this 1/2 in here, this 1/2, it's going to get distributed into the x and the negative 6. Well, a negative 6 times a 3 is a negative 3 is going to be a positive 3. We've got some like terms right here. So this is a 2x, 3 minus 5. A positive 3 and a negative 5 is going to give me a negative 2, and this is a 2x still, equals a negative 1/2 x plus 3. So I'm going to add 2 to this side and this side, and I'm going to add 1/2 x to each side as well. Why am I doing that? I'm just balancing these equations, because that way those guys cancel, and I'm left with here a 2x plus a 1/2 x, which is a 2.5x, or if you put it in fraction, it's a 5/2 x, and that should equal this part here, 3 plus 2, which is 5. And I've now isolated for x almost, because now I've got one last thing to do, and that is, this is gray, this is not too bad. Whoa, what happened there? Oh my, what's going on? I don't know what that pen is all about. Let me switch it up. I lost my, I'll stick with the colors I've got here. I'll just do white. So now if I multiply by 5, whoops, no, that's not right. I'm supposed to be able to erase, well, whatever. There. Now if I multiply by 2/5 on both sides, or 2/5 on both sides, I'm multiplying by 2/5 on both sides. The 2's cancel, the 5's cancel, leaving just an x. And here the 5's happen to cancel just by coincidence. And look, x equals 2, which is exactly what I was expecting. X equals 2 right there. That's the intersection point for B. All right. So now the question is well, what's the y-coordinate of B? Well, the y-coordinate of B can be found by using the blue line, which is this one here, or the pink line. I'm going to use the blue line because look, this is already really easy. It's nice and organized. And so if I know the x-coordinate happens to be 2, then I can easily say, well, the y-coordinate is 2 times 2 plus 3, or the y-coordinate happens to be 7. And if you look closely, yes, the y-coordinate is 7. Okay? So I've now found that B, point B, has x-coordinate of 2 and y-coordinate of 7. And that's the closest line, sorry, that's the closest point on the blue line that is the closest to point A. And now I want to find the distance between these 2 points. Remember, the distance formula is distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared as well. I've lost some space. I'll move over. All right. And so I've got my 2 points. A, which is right here, 6, 5. All right. And I've got B, which is 2, 7. So I'm going to put those in there. So my x-coordinate for is 2, and my y-coordinate for point 2 is 7. And then I've got a 6 and a 5 over here, right, for point A, a 6 and a 5. So I'm going to put my my 6 for my x here, and my 5 for my y. And I'm going to subtract them, square them, and add them, and then root them. And that's our traditional distance formula. So my distance is, well, what's 2 minus 6? Well, that's 4 squared. What's 5 minus 2? That's 2 squared. Or, look at that, the square root of 20. That's exactly what we got before. Now, clearly, if I had a graph, I would probably just do this geometrically and solve it that way. But if I, again, wasn't provided a nice, neat graph, well, then I'd have to do it algebraically, which would be this method here. Hope that helps.